Hi, my name is Jackson, and today I'm here to give you a brief demonstration on delegate types, how to create them, and their usage within the C-sharp programming language, and by extension, the Unity game engine. Hey, Editing Jackson here. So there were a lot of issues with recording the audio for this, and I ended up having to redub a lot of it due to a bizarre echo effect that got added in. So, sorry in advance if there's any audio weirdness. I tried. So, in order to show this off to you today, I essentially just have a pretty basic scene set up here in Unity. You can probably put this together in like 2 minutes if you know your way around Unity already. I have the default camera and light, as well as 5 cubes here. These are just completely default cubes. I just offset them a bit so they're not all stacked on top of each other. And then I also just have an empty game object in here with a delegate demo script attached to it. I'm going to tab over to it in a second, but you'll notice that the public cubes parameter has been set to refer to all 5 of our cubes, and that our input value has been set to 2. So yeah, I'll give you a couple seconds to set that up on your machine if you're following along, and if you're not following along, then yeah, don't worry, I'm not offended or anything. Alright, now let's get into the meat of this tutorial. The code. For those of you playing along at home, I'll give you a couple seconds to copy down what you see here. And alright, that's enough. If it wasn't enough time, then just go back and pause the video. So, starting up from the top, we have our public parameters. That would be our list of cubes and our input. Afterwards, we have two colors that we're going to use later to set materials for those cubes, as well as a list of chosen cubes that we've selected. And then, right after that, we have a function that returns a list of renderers known as first and fourth, which will return the first cube in our list that we got from the Unity engine, as well as the fourth cube that we got. And then after that, we have our start, which contains a lambda function inside of it. So that would be the set of 2 sets of parentheses with a little equals sign arrow pointing between them. And then after that in update, so that first line we'll get to later once I start explaining delegates, and then the for each there, essentially, it iterates through our list of cubes that we got from the Unity engine, and it sees if that cube is inside our list of chosen cubes. If it is, it sets it to our active color. If it isn't, it sets it to our inactive color. And that final IEnumerator, well, we'll get to that later. Alright, so now that we're finally done with all the housekeeping, what is a delegate? What does that line up at the top do? Essentially, a delegate is a set of inputs and outputs that C# uses to describe a function. And that line up top gives a specific set of inputs and outputs, in this case a single integer as our input, and a list of renderers as our output. It gives it a special name and turns it into a data type, so that we can use that name to refer to any function with that set of inputs and that set of outputs. And now you'll notice that both our lambda function in start and our first and fourth right above it take in one integer and return a list of renderers. What that means is that they are both cube choosers, and they can be assigned to a variable that is of type cube chooser, which in this case our chooser. Essentially, our chooser can be assigned to mean either first and fourth, or that lambda function, or any other function with that set of inputs and outputs. I have a couple examples of things that would be able to, that are functions that take in a single integer and return a list of renderers. First, for example, we have first and fourth, which kind of ignores the first integer, but whatever. We don't need to worry about that. And what it does is, whenever we call it, it returns a new list of renderers that takes the first and the fourth element
takes the first and fourth elements of our list of cubes that we set within the Unity editor. Now, right here, so this is a lambda function. It's if you took money, you probably remember that, but if you didn't, don't worry, I just give you a quick rundown. So, yeah, this is the lambda function in C#. It's basically just inputs and outputs, or what we do with the inputs.
Right, so let's tab back to Unity and see what this does. And if I click play here, you'll notice that it turns the middle one red. And that's because our input is set to 2. And if I were to set it to something else, then that changes which cube is turned red because of the for each inside of our update. Now, Jackson, I hear you say, why are you using delegates for this? There is a much simpler way to do this that I already know because I'm so smart. And yes, hypothetical you are correct. Using delegates for this would be really silly. But I couldn't think of any simpler way to demonstrate it for this tutorial. So here we are. Anyway, let's head back to the code, shall we? So we've seen what happens with our lambda function as our option here. But what happens if we want something else to be our chooser? Let's say we want to use first and fourth here. So what I can do, remember, our chooser is a variable, and it can be assigned to any function that matches the parameters of the delegate. Now, one thing there is that you'll notice that I put in first and fourth without the parentheses added on. That is important because if I had the parentheses, then C# would be searching for the output of that function rather than the function itself, which in this specific case is actually what we want. Alright, back to Unity. So now when I hit play, you'll see that in accordance with first and fourth, now the first and fourth cubes have been turned red, and it doesn't care about the input because first and fourth doesn't actually use that input parameter. Now, you're probably still not sold on the usefulness of delegates. Like, why am I even here? So, essentially, the real power behind delegates is that you can do anything with them that you would do with any other data type. So, as an example here, let's finally get to that IEnumerator that I sort of brushed over earlier. In case you're not familiar with the syntax, this is a Unity feature known as a coroutine. However, that is an entirely different tutorial, and I do not have time to get into that today. So just know that essentially what it does is it takes in a list of cube choosers, and then it cycles through them every second. Note that I said a list of cube choosers. We can do anything we would with a delegate that we would do any other data type. That came out weird. Anyway, so you'll notice here that I am creating a list of cube choosers. First and fourth, our lambda, and then also another lambda. Let me just do I+2, and then also I should probably do some mod code so that it doesn't throw out of index errors. That would be annoying. And yeah. So now let me just copy that and do one of those, and now let's head back to Unity. And hi, we're back. Had to do a bit of fixing off camera. I moved the call to our coroutine into start because it was calling it every frame and that was causing problems. And anyway, this is why you test your code and rehearse your demos before you record them. We're all learning things today. Anyway, so now let's tab back to Unity and watch it cycle between these three functions we've created. So now if I click play, you'll see that it is going through all of the different functions that we have placed into that list and evaluating them all one at a time when it chooses to. This can be incredibly useful For example, let's say you're building an RPG and you want to create a series of attacks. Maybe you have a player class and oh dear, great, I broke it. This is entered the stupid index error. Anyway, so let's say you're creating an RPG, you have a player class and an enemy class. Maybe you could create a coroutine type for spells that can use your player stats and inflict damage onto the enemies based on them. And then you can have a full lookup of them and and bring specific functions out of it for when you need them. That's just one way that you could potentially use coroutines in your code. I hope you found this tutorial useful and that this knowledge serves you well in your C# Unity adventures. Cheers!